Lesson 3 of Chapter 0 is on quadratic functions and equations. We're going to focus on graphing quadratic functions. Now, a term that you probably have heard before is a parabola. So quadratic functions produce graphs that we call parabolas, and parabolas are U-shaped graphs that open up, and then some of them open down. So that's just the general shape of a quadratic function or a parabola. So, first example says to graph this equation by making a table of values. Well, before you start making your table of values, what I would do is recognize if this parabola is going to open up or down. If we have an A, a B, and a C value that is determined when you put the equation in standard form in descending order. So the A value is 2, the B value is -8, and the C value is 4. And then off of that, you can find the axis of symmetry by using this equation. That'll give you the axis of symmetry, which divides the parabola into two symmetric parts. So if we were to use the -b divided by 2a formula, that would give us 8 divided by 4, which is 2. So that's beneficial when you make your XY table. When you make your XY table, I would encourage you to make 5 points. And in the first point, you're going to start off by putting that axis of symmetry value in the very middle. So 2 is the first value, then we'll go 1 point larger, and another one larger, and then we also go smaller. Okay? And so those are going to be my x values. Now if you plug each of those x values into the equation, you'll get corresponding y values. But to save ourselves some time, we won't have to put in all 5. Let's put in 2 first. If you put in 2, you should get 8 minus 16 plus 4, which gives us a -4. So that point right there that I just came up with is called the vertex. Talk more about that in just a minute. Now, I can put in a 1 or a 3, and they should produce the exact same outputs, or y values. Since it's easier to put in a 1 than a 3, I'm going to do that now. And that would give us 2 minus 8 plus 4, which is a -2. And then likewise, I can put in a 0 or a 4, and I should get the same outputs. And putting in a 0 is easier than putting in a 4. And if you put in a 0, you just get the C value right here. So that's +4. So there's your XY table. Once you get that XY table, you can plot those points to produce your graph. If you take a look here, we have an XY table that's pretty much the same thing I did. It's just a little bit less condensed. But here's your x values, same x values that I had. Here's your y values. You can notice that there's symmetry involved in that. And then here they are just rewritten as coordinate points, so that you can come over here to your graph and you can plot this point. That's the vertex right there. That's the point where it begins to open up or down. And then you've got 2 symmetric points and 2 more symmetric points to produce your parabola. So as I mentioned, this formula here is an important one. X equals -b divided by 2a. That's going to be something you need to remember or write down someplace. And that helps you find the axis of symmetry. And once you find the axis of symmetry, then you can identify the vertex by taking that x value and putting it into the function to find the corresponding y value. And then also, it's important to know that whatever your c value is, that represents the y-intercept of your parabola. So example 2 simply says use the axis of symmetry, the y-intercept, and the vertex to graph this function. So making a table of values is always a good idea, but let's use that formula to first find the axis of symmetry. So let's see here. If we do -b divided by 2a, that should be -2 divided by 2, which is -1. So there's your axis of symmetry, which means that your vertex is going to be -1 something. And to find that corresponding y value, you have to put -1 into the function. Let's do that over here. So it looks like the output we get is -4, so there's the vertex. And then the y-intercept would be at 0, 3 in this particular case. So once you know those parts, the axis of symmetry, the vertex, and the y-intercept, then it's pretty easy to make your graph. You can see here we've got the axis of symmetry, this red vertical dashed line at x equals -1. I've got the vertex plotted right here at -4, and then we've got the y-intercept plotted right here at 0, -3, which means it has to have a symmetric point right over here at -2, -3, and then it's just a matter of finding maybe 2 more additional points to produce your graph, and it looks here like we found these 2 additional points, 1, 0 and -3, 0, to produce a more accurate graph.